Cribl's innovation is its simplicity and its scale. Let me explain what that means. It's simple in the sense that it delivers immediate ROI. Customers get what it does right away and where it will fit. And it's scalable, which is its superpower. It allows for organizations for the first time ever to scale their data infrastructure in a manageable way.
At the foundation, the thing that really struck me about what makes Cribl so innovative is that they collect an enormous amount of data. They shape that data, they route it, they do it across infrastructure and security and applications. They can do it at a massive scale, and they can do it with low code or no code environments that getting all of that to work is incredibly difficult.
Cribl really empowers organizations to route their data to whatever place is best to store it and whatever place is best to analyze it. That's the sort of freedom that people just haven't had with machine data or with observability in the past.
Investing is very personal. We see so many opportunities, and there are plenty of good ideas, great ideas. The team is brilliant, and to a person, people reminded me of that: customers, vendors, etc., competitors. And then I watched former colleagues join the company also, and it just gave it it gave it like the personal fabric that I felt like this was a group that I wanted to be in business for a really long time.
What convinced us to invest in Cribl was the right team, the right product at the right time, addressing the right market opportunity.
The team is really what got us most excited. I mean, in the end, as venture investors, we're investing in a group of people that we think have a chance to do something really disruptive. And when we had a chance to meet the founding team and the management team that they had built, we were convinced that this was a really special opportunity.
I think Cribl is going to be a new strategic layer in the data stack. It's as simple as that.
The process of getting into Cribl as an investor in 2021 was not for the faint of heart, which I interpret as, supply and demand. If more people want to be involved with the company than are allowed, it suggests to me that they're onto something.
We're honored to be partnering with the team at Cribl and are huge believers in the value that they can create for enterprise customers of all sizes, and we look forward to the journey ahead.
Cribl is one of the fastest growing companies we've ever seen in the enterprise space, so that growth alone was something that was really exciting to us.
At Sequoia, we like to say if data is the new oil, then Cribl is the new pipeline.
I believe Cribl has the opportunity to be one of the largest software companies of our generation. The market is enormous, the product works magically, and we're winning.
we look at Kafka in production, the simplistic world of here's a broker, and here's a bunch of producers that's sending data to the broker, and here is a bunch of consumers that read the data, kind of, I wouldn't say fall apart, but it's getting to be much more complicated. In other words, the slide that I showed you earlier around brokers, and the brokers have the ability to receive data and then also giving you ability to consume the data from it. This is the part right here in the middle. It's called the Kafka Brokers. And by default, Kafka actually recommends a minimum of 5 of those because of fault tolerance and rebalancing and the like. So that's the Kafka broker. That's the piece right here. At some point, Zookeeper was really important. And in the demo that I'm running, Zookeeper is the one that keeps state, the one that keeps configuration, the one that keeps a lot of the knowledge is done through Zookeeper nodes. However, in the latest releases of Kafka, they're moving away and they're getting rid of Zookeeper. So that's a kind of another part of it. Again, you'll see 5 boxes here because when you look at the recommendation for production, they're talking about having an uneven number of Zookeeper nodes, and they also recommend a minimum of 5 of those as the minimum. And right here on the right, there is this box called Confluence Control Center. So if you download Kafka, the open source, you won't get this. You will not get any UI whatsoever. But if you download Confluence version of Kafka, they have a fairly decent management console. They call that the Confluent Control Center. That allows you to add brokers, rebalance things, create new topics. So everything is done through a UI. So that's this part right here. Another part that is important is the one we mentioned, the Confluent KSQL or streaming. Those are, for the most part, do not come with Kafka, but can be added to it. So that's another part. They have the Confluent REST APIs, so you can use a REST API to access Kafka and retrieve data from Kafka. And then there is another piece that is kind of important. That is the Confluent Schema Registry. In Cribl, we do support that. It's the ability to store schema. And basically, if it's an Avro file that you want to store in Kafka, and Avro is binary, you can use the schema registry, the Confluent schema registry, to understand what is the what are the rows and columns of those files. And so that's the schema that you can you can store in part of this ecosystem. And the last part here is Kafka Connect. Kafka Connect is important not because Cribl is using it, it's because Splunk is using it. Kafka Connect is the way that when you look at Splunk and you look at the Splunk app for Kafka, and I might be butchering the name, they might calling it something slightly different, they use the Kafka Connect mechanism, which is its own set of workers, own set of Java virtual machines that allows you to go in and retrieve data from Kafka and actually send data to Kafka. And in the case of Splunk, they're using the Kafka Connect. We in Cribl do not use it. And so that's kind of the technology details, so to speak. Whenever you do use Kafka in production, you will get to this level of configuration. And so, as I mentioned, this part right here, the Kafka brokers, can be from 1, 2, 10, or 4,000 Kafka brokers. And so whenever you look at use cases that were published on the web by Netflix and a few of the others, users of Kafka, you're talking about thousands of these brokers. And with that, let me go into the next part, which is Kafka and LogStream. Are we friends or are we not? And so, Scott, I saw your question. Are they viewing us as a competition? And I would say yes and no. On the basic part, which is the friend part, the answer is no. They're using us. We use them as a message broker, and we complement their solution. But on the stream part, if you are a sales rep and your main way of making income is the Kafka stream, the answer is yeah, for sure. And so on the friend side, I did some digging, and the very first version of LogStream, way before I joined Cribl, in LogStream version 1.2, we supported already in that version, we supported Kafka as a source and Kafka as a destination. Since then, we added quite a few features there, but as you look at how we do it under the cover, we are using Kafka as a pull source, and I will show it to you in the demo. And approximately every 5 seconds, we check. Basically, the worker processes pull and check if there is new data on the broker. All the Cribl worker processes are treated as part of a consumer group, and the consumer group is a very important part of Cribl and Kafka. It is the way that we manage our connections, and the consumer group is the one that tell each and every one of our worker processes to tell us what part of the message you need to read, what events have you read already, and so on and so forth. So the consumer group is a very important piece of technology that Kafka provides that we leverage as part of the Cribl implementations. For the most part, there is no dependency, and this is important, on the Cribl leader node. In other words, although Kafka is a pull mechanism, and many of our pull sources do have dependency on the Cribl leader node to determine what has been pulled already, what still has to be collected. In the case of Kafka, there is no dependency on the leader node. There is a dependency on the consumer group that does that for us. Also, a piece of technology that is important to understand is that we in Cribl, we use the libraries, the Node.js libraries called Kafka JS libraries to do all of these manipulations. Reading the data from Kafka, pushing the data to Kafka is done using the Kafka JS node libraries. And finally, one of the last features that we added as part of this implementation is the support for Kerberos. Kerberos as a way to authenticate between Cribl and Kafka. So that's kind of this part. As you can tell, for the most part, you can see that Cribl and Kafka has a long relationship, and from our point of view, it's an important piece because many of our customers already have Kafka as a pub sub, and so this slide is just kind of a little bit of a technical deep dive on consumer group. As we mentioned, Cribl, LogStream, we use the concept of Kafka consumer group. And as we mentioned, the Cribl worker processes So every single worker process is basically a Cribl. It's basically a consumer. So whenever we read from Kafka, and each worker gets its own share of the load by Kafka. And so as you can see, when you go to Cribl and you say, which group are you part of? The group has two parts to it. The group, first of all, says, what topic are you after? And then it tells the consumer, in this case, the Cribl worker process, where to read the data based on the partition. So what is this, a partition? A partition is basically a piece of log on the file system. It's actually physically stored on the file system. And each partition is stored subset of the data. And so as you are a producer, you add data to the partitions based on the topic. And as you, the consumer, you read the data from the partitions. And so this is kind of the low level of Cribl. Whenever we talk about Cribl worker processes, we basically, from a Kafka point of view, we are a consumer, and the consumer will map to a partition. And all of that stuff is done by the consumer group or by the leader of the consumer group. And in other words, there is a piece of software called the group coordinator, and that piece we don't control currently with our implementation. It's done automatically, where the group coordinator tells each one of our worker processes which partition to read and from what part of the partition we read already and what event still has to be read. And so all of that management is done by the group coordinator, and it's the one that is responsible for managing the state of the group. And its main job, quite literally, is whenever we have new members. And what does new member really mean? Every time that you restart your worker processes, every time that you update Cribl nodes, in other words, worker nodes, and you have more worker processes, the worker processes stopped, and then they rejoin the worker node. Every single one of those events means a consumer is gone or a consumer is now available. Every time that we have new member arrive or depart, every time an act like that happens, you will see under the cover, you will see something we call the rebalancing. It's basically the process in which the group coordinator says, I now have to figure it out, Mr. Worker Processee, which part I'm giving you to reread or which part you have read already. Everything here is done by automatically. So from an end user, you don't have to worry about it. However, I'll touch upon that in the best practice. The group coordinator is a really important piece of the puzzle whenever we talk about Cribl and Kafka. So that's kind of, sorry about the truly deep dive, but that's how it's done under the cover. And that is the importance of Cribl with Kafka group coordinator. And that's the way our engineering implemented this solution. With that, let me go out of slides and into the demo. And in the demo, I'm going to dive into the give or take 6 different options that we have to work with Kafka. Turns out that with the current version of Cribl, we have Kafka as a source, Kafka as a destination. Confluent, the paid version, have a version that they support in the cloud. As I mentioned, they give or take, based on the latest report, they reported about $20 million ARR just on this part. So we have that as a source and destination. And the final one, Azure itself, Azure Event Hub, both source and destination are nothing but Kafka as well. And so with that, let me go into my demo. And let me click on one of my default worker group, and let's go into a source. And so as we mentioned in Cribl, if you want to read data from Kafka, you go to the pull section of Cribl, and either you click on Confluent Cloud to read the data from the cloud, Azure Event Hub, again, another Kafka version, or the one that I have here is just a simple on-prem Kafka. And what I have here, whenever you set up Cribl, you tell Cribl, LogStream, where is your Kafka broker resides, what's IP, what host, and from that point on, the next part is you have to tell Cribl which topics, and you can have multiple topics here, which topics you would like Cribl to read from. And the next part is, now that we have the topics, the next part that is important for that puzzle is to specify what consumer group, the one that identified which partition you're going to read from, are you part of. And so you can have multiple group IDs. In other words, you can add more and more Kafka mapping of a group ID and a topic. So that's another part whenever you configure Cribl. And then the flag here that we see is from the beginning or not from the beginning. It basically tells Cribl, I'm going to read the data from Kafka and I'm going to go to a specific topic, should I go to the beginning of the partition or not? And this one is really just important in the initial part. After that, the consumer group knows what you already read and so on and so forth. So that's kind of a few parts of the configuration. We do support the TLS. We do support the authentication that we mentioned earlier, the Cobros, and a few other options are part of this integration. And so if you do set up the latest and greatest Cobros, you have to provide the key tab and the principal. And there is another piece that you can specify the Cobros service class. So there is a few settings here that I don't have in my demo, but are part of these capabilities of Cribl and Kafka. The other part that we mentioned is schema. What if you have Avro files that are binary and and there is not really an easy way to read the schema? Cribl also support the schema capabilities of Kafka, and usually that's a different engine by itself. It does not necessarily going to go to the broker, but it has that kind of schema registry is another capability that we support. And the last part that is kind of important to note is this kind of capabilities of session timeouts, and it's kind of all the different configurations that Cribl expose to make sure that whenever we join a group, whenever we talk to any consumer group, there is boundaries about how long do we wait. The rebalance timeout, it's also another important piece. And so whenever we talk about best practice, we definitely talk about many of these flags that Cribl exposes to make sure that we join the group, we depart the group, whenever there is a rebalance, and every time there's a rebalance, we are unable to read from Kafka. So all of those kind of capabilities are part of the advanced settings of the Kafka source. And just kind of to finish this part of the demo, I have, in this particular case, I have a Kafka system running. And as you can tell, there is no UI involved in this Kafka environment. The top box here is just my Cribl system running. The box on the left is Zookeeper. In my case, I have the open source version of Kafka and I use Zookeeper. And the box right here is basically the broker.
Yes, please, ketchup.
And,
I want mustard.
Exactly. And as part of the Kafka broker, you can see that when Cribl joined the Kafka broker, the group name that I gave Cribl was part of the Cribl broker was designed to tell Kafka the name of the group and the name of the topics that we are interested in. And so that some of the information that you are able to see as far as rebalancing, and there is kind of every time there is a new worker process join, you can see all of that information available in the Kafka logs, or if you use Confluent UI, you can see a lot of the stuff in a much nicer way. But there is a lot of information that you can find by going through the log and see everything that we mentioned around rebalancing. And every time there's a rebalance, again, you cannot read from the data, and so on and so forth. And that's where, in many cases, if you debug Kafka, this is a great place to start, or the logs that are basically stored from this input. So in this particular demo, and it's a very, very simple demo, I have a manual way of entering data into Kafka. I'm using a Kafka producer. I am going to put the data into a topic called Quick Start Event. And on the Cribl side, and also I tell it where to, basically the producer put the data into Kafka, and we will read the data from Kafka. And so from a Cribl point of view, we definitely need to know which topic to listen to and the IP of Kafka. So with that, let me put some data into Kafka. So as I'm starting, 1 second. It looks like I have some errors. And let's see if I can get this data in Cribl. It worked a minute ago, so hopefully that error that you're seeing will appear in Cribl. And yes, it does. So the warning is just a warning of some timeout. And so this is kind of a very simplistic way of seeing Kafka in Cribl. Is you can go in and you can test all of your environment by using a producer. This piece comes out of the box in the open source of Kafka, and you can add new events into Kafka and then ask Cribl to listen to your topic. And as you can see from here, this is as simple as that from a Cribl's point of view as the source. On the destination side, very similar to the sources, you will see Kafka, and there is slightly different flags that whenever Kafka is not the source, but Kafka is the destination, you will see things like which topic you want to send the data to. The acknowledgement is the whole notion of confirmation that the data made it into Kafka. And there is 3 different flags in here: the leader, the no acknowledgement that the data made it, or all, in other words, all of the producers have to confirm that they received the data if there is a data redundancy. And so there is several flags that are available as far as acknowledgement. The data format that we in Cribl send to Kafka comes in two flavors, either a JSON or raw. As far as compression, you can either have no compression at all, use gzip or snappy, and there is also pros and cons for using one or the other. Gzip has probably the best compression, but it takes longer to compress the data. Snappy has not the best compression. It probably gives you maybe 50% compared to raw, but it does it in a much faster manner. So there is several flags here that you can use to get more data from a performance point of view when you send data to Kafka. And so that's kind of the information that you can provide. Another piece of information that's really important, and I'll talk about in the best practice, is there is this flag that allows Cribl to dynamically set up the topic. We call that __ topic out. You can build a pipeline, and instead of having all of the events go to your event that you specified as the destination, you can actually specify that on the fly. And so that's kind of as a best practice point of view. Obviously, as you expect, if Kafka is down, we can enable persistent queuing. And there is a few other flags that are important for this set. It's the whole notion of what's the size for each record. And so this is pretty much set up to very close to the max event size of Kafka itself, and how many events can you send in a single batch. And so there's several flags right here that are important to understand whenever you talk about Cribl and Kafka as a source as well as a destination. And as I mentioned, Confluent as a cloud is another one. And the last one is Azure Event Hub is also yet another implementation of Kafka. And actually, when you hover over that, all of those things, all of those flags will look really familiar compared to the basic Kafka implementation. Bottom line, that we're even calling it a broker. So that's pretty much what I have as far as this section of the demo, just to show you that there's a lot of capabilities that we enable between Cribl and Kafka. And now let's talk about when Cribl and Kafka do not necessarily see eye to eye. And in some cases, customers will compare Cribl persistent queue to the Kafka message broker storage. As you know, in Cribl, we have this ability to store data if the destination is not available. We call that persistent queuing. And this is somewhat similar to what Kafka doing it, but in our case, I would say if the customer is trying to compare Cribl messaging, persistent queuing to Kafka message broker, I would say it's not the same, because in our case, it's just for a destination. We don't keep it. Our goal is not to keep the data for days. It's purely for our purpose. And persistent queue does a little bit of what Kafka can do, but for the most part, I would not really consider that as a Kafka competitor. It's just a really nice feature of Cribl. Where we do see a much more set of competition area is around Kafka Stream, as we mentioned. In Kafka Stream, you can do data reduction. You can do data enrichment. There is the whole notion of deduplication. They have those APIs that can do that. Transformation. Kafka Stream can do all of that stuff. They can change the data from one format to another one. They do have aggregation. And Kafka Stream also have a capability to do stateful. And in Cribl, we do not do stateful for the most part, unless you use Redis, and that's slightly different. But those type of use cases come into play if people use Kafka Stream. Our biggest advantage over Kafka Stream, by far, is that we don't have to store the data back into Kafka. We are totally independent of Kafka. And so most of our customers use Kafka messaging with Cribl and do not use Kafka Stream. So that's kind of where we see some of the overlaps, is if the customer use the Kafka Stream mechanism. And this is kind of what Kafka Stream actually looks like. Basically, you have to write code. And so that's another part, another major advantage of Cribl. It's the whole capabilities of truly ignoring our end user is not necessarily have to deal with this type of code, but as far as capabilities, as far as what can Kafka Stream do or cannot do, they have a lot of capabilities. The ability to, like I mentioned, aggregation, enrichment. They have this piece called KSQL that can also do queries against Kafka. But bottom line, in Kafka, whenever customers use Kafka SQL, Kafka Stream, the assumption is data goes in and out from the Kafka broker. And that is truly not the case with Cribl. And with that, let me go into the next topic, which is Kafka best practice. And the very first topic I have is around sources. Whenever you read data from Kafka, the very first thing we would like to see, again, in a world in which you have only Kafka as a source, and in the world in which Kafka is the only one you have to deal with, we would love to see a one-to-one mapping between the Cribl worker processes, as we mentioned, to the number of partitions that you have for a specific topic. That is the ideal situation from a Cribl point of view. So if the customer, if you are, the only thing you care about is just Kafka, and in many of our customers, it's not the case, but let's pretend you do have that use case, we love to have a balance of a one-to-one ratio between the partitions, like we said, the logs that Kafka store the data, and the worker processes. So that's the ideal. Not ideal is the use case where there is imbalance. For example, if you have more worker processes compared to the number of partitions, some of those worker processes will not get data whenever we read the data from the Kafka partition. So they'll be unused. Or the flip side of that, if you have less worker processes compared to the partitions, in that case, you get the opposite, where a consumer will get, we will have a kind of a hotspot where some of our worker processes will get more data compared to others. So I totally understand that this is not the reality. In many cases, Kafka is just one source for us compared to multiple. But if you had the ideal world of a mapping between the worker processes and the partitions, it will be a one-to-one mapping. So that's best practice on sources, number one. The next part is the whole notion of seeing too many group rebalancing warning in the Cribl logs, or in the, or actually you can see the same thing in the Kafka logs. And in the Cribl logs, it comes into, you will see the group is rebalancing or rejoining. So this error happens because every time that you start a worker process. Every time that you restart a worker process, the coordinator, as I mentioned earlier, the coordinator is responsible for rebalancing. So this act may happen over and over again if you do lots and lots of restarts. So that's, and every time there is a restart, there is a pause in the data consumption. And so to avoid some of those rebalancing, to avoid some of those issues, some of our customers, some of the Cribl customers went to the same advanced setting that I showed you earlier, which is a session timeout. It's all about group management. In other words, increasing those values may, in some cases, and also maybe having a dedicated worker group just for your Kafka source may have some major influence on how many times Cribl has to pause because of rebalancing whenever reading the data from Kafka. Again, these are all kind of part of the best practice as far as how do you tune Cribl and Kafka. And so those, whether or not it's a one-to-one mapping between the worker processes and the partitions, or increasing the flags, the timeout flags, whenever we talk to the consumer group, those might help on seeing a better performance and less restarts of the reading. One more thing that I saw is kind of when I was digging this kind of best practice is we have some customers that all of a sudden report that all of a sudden the Kafka source start failing, and it's usually because somebody else, another Cribl instance, funny enough, just use the same default group name, which is Cribl, and with the same topic. And at that point, it will pause. One of them will basically will not be able to read from Kafka. And so there is a simple workaround to that. Just change the group ID. It's part of the UI. And don't select it from the beginning. At that point, you can continue reading wherever you read before. So those are kind of best practice on the source. On the destination side, as far as best practice, we have, as I mentioned earlier in the demo, the whole notion of __ topic out. So we have many customers who use that as far as a best practice to tell Cribl on the fly. In this particular demo, I have 2 versions of SNMP, and if it's SNMP version 2C, or if it's SNMP version 3, I set up the Cribl to send the information to a different Kafka topic. We definitely recommend people to use this to apply topic name dynamically instead of statically through the just the destination. So that's one best practice. And another best practice that we saw really work well is by default, as I mentioned, again, on the destination is if Cribl is limited by the size of each event. Each event by default is 1 megabyte, or what we have set up here is 768 KB. And if you have larger events, or even if you want to push more data, we highly recommend you use the snappy compression just to get about 50% more out of your, as you send data to Kafka. So snappy can be very beneficial as far as sending more data to Kafka. So that's, again, best practice. And with that, I'm going to go into the last section, and that is how are customers using Cribl and LogStream, Cribl, LogStream, and Kafka in production currently. And so this use case, it's a customer that use Kafka as a source. And in this particular case, that customer has many, many other sources that do not go through Kafka, but they do have several that use Kafka. And in this case, Kafka is the source. We enrich the data from Kafka, and then we route the data from Kafka to the customer's SIEM solution, to Elasticsearch, and to S3. And so this is how we can complement Kafka as a source. In addition to that, for that particular customer, they had several other sources that has nothing to do with Kafka, and Kafka was part of the ecosystem as yet another source. So this customer is in production right now, and that's one example. I found another example where this is a different customer that use Cribl before they send the data to a Kafka. In this case, Kafka is a destination. And in this case, Kafka is actually sending it to a different system, to some alerting capabilities. So this particular customer, if they use Splunk as one of the data sources, and whenever they see specific key value pair, they send the data. If it matched the criteria, they send the data to Kafka, and from Kafka, it goes to yet another system that use Kafka as a consumer. So from Cribl point of view, Kafka is a producer. We use Kafka as a producer, and there is a consumer on the right side here. Also, this customer is using a SIEM solution, and also this customer is using Splunk as a destination, as well as Syslog and Splunk HTTP Event Collector are some of those sources. So Kafka, in many cases, is part of the Cribl ecosystem for many of our customers. And I was able to find quite a few customers that use the two together. For example, this customer is used Cribl to replace Splunk Connect for Kafka because we perform much faster. And also, this same customer used selective routing, very similar to what I showed you in the best practice. Customer number 2 has also Splunk UF sending the data to LogStream, and LogStream basically does deduplication. Duplicated data, basically routing data to both Kafka and Splunk, and quite a lot of other customers that customer number 3 is Elastic to Kafka, and then from LogStream. Customer number 4, another one that uses Kafka as a source, and LogStream then does enrichment, shaping, filtering, and then send it to Kafka. Anyway, there is another customer that actually use the Splunk journal.gz and then send the data to Kafka. Anyway, there is quite a lot of capabilities around sending the data to Kafka or read the data from Kafka. And these are just some of these use cases that I was able to find that some of our customers using the two together. And so just to recap, Kafka business is going very strong. No connection to Cribl. Kafka technology, 2 main parts are, as I mentioned, the message bus, which is most of the revenue come from that, as well as the streaming and case SQL, which from a Cribl point of view, it's very much more of a competitor than a complementary solution. Funny enough, Kafka does not necessarily consider us as our main competitor. They don't consider us, mainly they consider us as a complementary solution, but they consider Pulsar, Apache Pulsar, to be their main competitor. And the final thing that I have here is LogStream has many customers who are using Kafka as a complementary solution. So that's pretty much what I have on the subject.
All right, thanks, Renan. Any questions? And I'll keep recording if we have to go over for those folks that have to drop at the top of the hour. Questions? for Renan? All right. Well, I appreciate it. We all appreciate it, Renan.
Yeah, thanks, Renan.
Did I hear a question?
No, I was saying thanks, Renan.
Totally pleasure, Michael.
Yeah, that was great.
Good job, Renan.
We'll have this up on YouTube. Sorry, on YouTube eventually. In 2 weeks, on the 23rd, we've got Igor. He's going to cover using LogStream as your security pipeline. So we've got another topic coming up in 2 weeks as well. And thanks everyone for joining.
Thank you.
Thank you, guys.
Recording stopped.